I've got to wake you up. You've all had food. Yes. So always go through what the talk's going to be about so that if you're in the wrong room, you can leave, and I won't be embarrassed. So this is a pretty fun talk. It's about how you've written code in the past that wasn't how you should have written code, but it worked. This is not instructions on how to write something. This is important that if we take this away, it's that at times you have to write really ropey stuff, but you shouldn't aim to do this, right? That's not the goal. I'm head of engineering at a fintech in London called Free Market, and they're very kind and allow me to spend a day going to conferences and things like this without making me take holiday, so I'm very grateful to them. So what I'm going to start with is if anyone's done retrospectives, this is a really common thing that people show at the front of a team retrospective, which is pretty much people kind of did the thing they needed to do and they tried to do it to the best of their abilities. And you shouldn't really blame them for what they did. You can talk about it at a conference later, maybe, or talk about it in the pub and have a laugh about, I cannot believe we coded this. But it really is an example, this is a prime example of how we did what we thought was best and it worked. So I had to go for some kind of timeline. I was thinking of mobile phones and stuff, but instead I went for the calendar that happened to be in my home office. Who wasn't born in October 93? Yeah, you say, God, yeah, it's quite scary. This is me coding in October 93. So this is the first job after university. And it is the Sky News weather system. So I hope quite a few of you know Sky News, which is a news channel from Sky B. They had no internal weather system. They were having to hand draw all their maps. And I was part of an independent company, and we produced the first ever in-house weather system for Sky News to take in satellite information and put the little symbols on a map, which, similar to here, are normally rain, right? I mean, similar to here now, not similar to here for the whole year. You get a lot more sun than we get. So, but this is back in 1993. So how do you do a weather system? Well, you've got Windows 3.1, right? So we had PCs like this with really big floppy drives that were that big and things like that. So you're working with that, but also one of the things we had was this really high-end graphics card that could do broadcast television graphics. It cost £2,000–3,000 then, so that's like 10,000 euros now kind of level of expense. And on it was a little coprocessor of its own that could render things. The boss of the company had actually written an interpreter that could take instructions and render symbols and graphics and pieces of text. And the way you talk to it is you sent stuff down an RS-232 serial cable from the Windows 3.1 PC to this other Windows PC to load onto that coprocessor to do graphics. And then that card would send out really nice, pretty broadcast graphics. The sort of thing you're used to seeing. And even then, graphics looked nice on TV at that point. They were just hard to do, right? So, but how are you going to create these things? Because you're not going to write an art program. That would be madness, right? And this coprocessor, what's a good way of describing graphics that you can send quickly down a serial cable? Turns out, encapsulated PostScript. So you can save things as a kind of squished version of PostScript and send it to someone else, and then they can render it. And how do you do that? You use CorelDRAW 3.0. That is genuinely the kind of colors you used to see in it because you only had 16 or 256 colors. There was no 24 million colors, right? That was just dream. That's what your graphics card did, and that's why it cost £10,000. So we used that in order to do a map of the United Kingdom and to do symbols and to do things like that. But we had to drive it. So the weatherman at the time, when we first showed him the system, I had to say, obviously you use the mouse to do this. And he goes, what's a mouse? So I was having to show him what a mouse was. So he's not going to do his art program natively. So what we did was we used this new tool called Visual Basic 1, right? And what we could do is create little forms, like that calculator form, and sit them on top of CorelDRAW. CorelDRAW was maximized, and then we put little toolbars all over it that was RVB code. And when the weatherman said, we need a sun, or we need a temperature symbol for 25 degrees C, we got VB to send keystrokes to CorelDRAW. And we sent Alt-F, I for import, then it searched in the right place on the file system to load the graphic we needed to load. Right? And we went mad and took this to ludicrous extremes, where we actually had on a map where you would see there's a hot sunny area and there would be a blue area and a gray area for rain. The weatherman could actually draw an entire area, and then in this overlay, I have none of the code, so I can't show you what it exactly looked like, and they'd press it and say, I want this to be rain, and it would group whatever they just drew to a tiny 2x2 pixel little square at the top that would be exported separately to be rendered as the blue area, and one to be rendered as gray, and one to be rendered. And you're thinking, what on earth did this end up looking like? And it ended up looking like that. So that is a legitimate one of the maps that came out of this whole system. So all the text was native text. They could just write text on top and give it a color. All the symbols were automatically pulled in, and if it was, say it was above 20 degrees, it would be orange. And if it was below 5, it would go blue, because everyone understands that's cold, so it must be a cold color. And that whole gray area would have been seen. And when it rendered, they got to see it render live, and then they captured it inside a graphics operator. Had to go, I'll capture it now because it's finished. That used to take 30 seconds to render the gray, because it actually did a spray can as an outline to get a soft edge, and then filled the whole of it with black. And all via encapsulated PostScript. But this was a system that got created for about £5,000, and at the time, a company who wanted to do it properly, externally, was wanting to charge over £100,000. So quite a good solution to get away with it. So that was my first introduction to kind of how to hack your stuff at Sky. We eventually also did things like weather radar with rain coming in and clouds, but that we had to do differently. We could only do that at 640 by 480 pixels, which is quite a bit smaller than it should be for a broadcast TV. And we used something called Autodesk Animator Pro to load in individual files and then render them into a moving animation that a card mirrored the VGA from the PC out as broadcast video, and that's really expensive as well at the time. So that's how we did even radar and clouds and things like that. So that was the kind of introduction. And I would point out that for those of you who've never done VB1, it didn't have a cohesive ID. All these windows were separate. And they thought they were still in C land because they called it a make file, not a VB project. So it was just horrendous to work with, but really fast to develop. So we carried on doing computer graphics. By now, I'd stopped working for this independent company, and I was now working in-house for what was now the broadcast computing department. And we had started with 2 or 3 people, and we did all sorts of things like sports results, the clock in the corner on a football match that tells you the time and extra time and does goal scores and things like that, all that. Finance results, all the sorts of things we could automate. We could take data, push it out, automate it, and no one had to hand type it in. But there was also an entertainment channel that they wanted to. They had a main entertainment channel called Sky One, and they realized they could fill it in the morning by just showing music videos. And they created an entire segment, unbelievably, called Morning Glory, which, if you know what Oasis, why Oasis gave that a name to their album is a bit dodgy. But this was their channel on the family entertainment channel. And they wanted a clock in the corner so you knew what time it was because you were going to go off to work or take the kids to school, all that kind of thing. That's why the breakfast shows all have clocks on. And I can't spell video either, by the looks of that. And what they said was, we'd like this to be a sunflower, like it's the morning, but that's a bit boring. So what we want is we want the sunflower to change color. We want it to go from yellow over to green, then to blue, probably blue next, then purple, then red, and then back to yellow, and, so it's quite nice. And we said, that's great. That's superb. Right. Goes, we've got the kit to do the graphics. All you need to do, we said to the designer, is you just need us to give all the sunflowers with all the different colors. And they said, oh, yeah, here you are. Gave us it on probably about 8 floppy disks, because one image on TV is one entire floppy disk, 3.5-inch floppy disk, full, right? So they handed these over, but all they did was give us a yellow and a green and a red and a blue. And they said, yeah, you can blend them, can't you? You can write the code that just makes them go from blue to green. Can we? Yeah. So we thought, right, we're VB programmers. We've only been doing it for about 3-4 years. We're in VB3 land at this point, something like that. And its handling of binary files is pretty poor, right? So we had a thought, I know what. I think what we can do is we can load, and I'm just going to start this virtual machine up. We're going to load the graphic that's a bitmap file, BMP file, into a string, because it's really easy to load things into strings in VB. And we're going to use a really special thing in Visual Basic, and an old version of Visual Basic, not VB.NET, because you can't do this in VB.NET, as I found out when I had to create a VM so I could install VB6. Right? Do you know how hard it is to get XP to install? Because they've stopped all the license servers, and they've stopped the service packs being available, and the integration components. It's not the easiest thing in the world. So we decided to use something really special inside of VB. So did anyone ever program in VB? The original VB? Yes. Right. There's something called midstring, or mid. And you could say, I want character 3 to 4. Can I zoom that? You probably can't even zoom it in the old Visual Basic 6. It didn't have a zoom function. So you're saying, I'm going to get this string, and I'm going to give you from character number 3, doesn't start at 0. It's VB. So that's character number 3, and it's going to be 4 characters. And the interesting thing is, not only could you get a string, you can set it. So you can actually go midstring 3,4 equals something. Right? So that's really freaky, because that was hidden in the docs. So as a demo for just plain text, to give you an idea of what we're talking about, we have a button saying hello world. We're going to take character 3 to 4, and we're just going to instantly inject some text into it. So what it should say is LLO, because it's character 3, and there's 4 characters, and unfortunately there's a space. And then we inject into it dash hi dash. And all of that happens without you having to reallocate a variable. So this is Visual Basic poking values into memory, right? But it's strings, you know. So obviously, that's not going to work with images. But an image is just data. And it's just red, green, blue values, 0 to 255. So you just need to set the characters to ASCII 0 to 255. So you just read the string in, and you say, I'm going from yellow to green. I'm going to take 1% of whatever the ASCII value is, and 99% of that, and that's my blend. And I'm going to do this all the way through all the colors, and I will directly poke all these values in and save every frame out, ready for doing an animation. And what you actually get to is a blue bitmap suddenly going cyan, magenta, and things like that. And the code for doing this is really simple. I had it down here somewhere. Is you just load an entire bitmap in to a string using an OLE component, file system object, because VB didn't really have anything like that. And we could just load it all in, read it all in. You can then poke values in, save it all out. And that's what we did. And what you end up with at the end of all that is a flower that starts changing color. So we delivered this to the engineering department. So whenever you said, hey, here's a piece of equipment, you've got to put it into your broadcast rack, and it's going to overlay the channel, so it has to work properly, because it's going to stop the channel going out if it goes wrong, because they're going to use it. And we gave them it, and the next day, he said, whatever I do, however I'm adjusting it, I can't get the color to stay the same. Right? He had oscilloscopes on and everything, and was trying to work out why this color keeps changing, at which point we had to say, it's meant to do that. Right? But we forgot to tell him. So, but yes, so that is basically bitmap manipulation in strings, for the sole reason that we couldn't be bothered learning how to do binary files in VB3, right? Because it was quicker to write it like that. And remember, this was a one-off render. We never did it again. So it's throwaway code at that point. So, but you learn that that's not the most sensible thing. You're getting onto VB4 and VB6 era. So May 1997 was a famous general election in the UK. It's when New Labour took over from the Tories, and Tony Blair was the new Prime Minister going, hey, everything's, whatever the song was, things are going to get better or something like that. I can't remember what the song was. We've done some local elections. So you always rehearse these things by doing the little elections, and there's European elections and local elections and things like that. And we weren't the IT department. We were broadcast graphics programmers. So to us, big databases were a mystery. It's VB. We'll do it in Access MDB. Right? The problem was that we had a Novell network file server. So this was just a drive letter. That was it. Nothing more than a drive letter that we were talking to. It had an Access MDB file, which one of the programmers polled really regularly to get information from. So regularly, we couldn't actually save new results to the file because he was locking it, right? Because he wasn't being sensible about how he was doing it. When challenged with your software didn't work, he said, no, my software worked perfectly, yours didn't. And we had the discussion for, probably 20 minutes. If you were in the discussion about conflicts, it was one of those kind of arguments that talk about conflicts. What we decided to do was we weren't going to convince him otherwise, so we're going to protect ourselves the next time we do this. We were looking at things like SQL Server. It was only at version 6.5. This was a version of SQL Server that would not make the database file bigger if you had more data, because otherwise it might run out of disk space. Because disks were so limited, you wouldn't want that to happen. And Oracle was something the IT department had. Weirdos in the IT department. So there's obviously a really good solution to doing this. If you kind of think about domain-specific languages, you may have heard of that phrase, a domain-specific language, we were kind of decided, maybe we need a different kind of database. One where we only allow data access via a central location. So there's one point you talk to get to this database, and just one point. While we're at it, why don't we cache all the data in memory? I mean all the data. All the previous results, all the new results that have come in. There isn't a lot of data in an election. Right? However much you cut it, there just isn't. There's 650 seats, 10 MPs per seat, or 10 candidates. It's not a lot of information. So you can put it all in arrays in memory. Really easy. And we'll make that central thing have exclusive access to the MDB no longer can someone block us writing to it, right? Because it's the only thing that can write to it. We'll talk to it with this new thing called OLE Remote Automation, which the VB team had written, which became DCOM. So you could remotely, over the network, talk to something as if it was a COM component on your own machine. And they'll connect to a WinForms app on an NT4 workstation over TCP/IP pipes. So if you're clever, you know that we've just written our own database server. We have a database file exclusively owned by this app. It communicates via TCP/IP connections, and it's caching the crap out of stuff. So it's a domain-specific database server that we decided to write. And what did it look like in the end? Well, we had our Novell Network file server still. That was still there. And that was on the IT network. So that's on business IT. And that's where our MDB file lived. Our central location was this DB server. Microsoft had just recently decided that people were abusing their license for Windows NT Workstation by running it as if it was a server. So they limited you to 10 connections, TCP connections, which meant, by the way, you could only download 10 things at a time in a browser, because that was 10 connections to the outside world. So we could only allow 10 connections to this, and that went through another bit of kit that was ours to get to all our broadcast equipment. We had results coming in from the Press Association. Virtually to a person, I don't know anyone who's really used RS-422 unless they were in an industrial factory. That's the same thing as RS-232, but it can run over a kilometer without degrading. So we were able to have it in a completely different part of the building to the data coming in. And then we had manual results were input by people on Windows NT Workstation. We had results viewers so that the people in the studio could see what the results were and could preview what was coming up. We had an election analyst use Excel, because Excel can do COM components, so it could talk to our database server and just pull all this data in. And then we used Windows 95 to do graphics, because our graphics card at the time needed Windows 95 and couldn't run under Windows NT. So we were running it on that using VB4 16-bit. And we were doing full results. And then we even had a Silicon Graphics workstation doing 3D graphics, so that you could have the Houses of Parliament with little men appearing. So where they go, oh, these are yellow, these are green, these are blue, all that kind of thing. And that is how we ran our system. And it worked. And it worked to the sense that at some point, and an election is you turn up at 10 a.m. on a Thursday, everyone votes on the Thursday, but you're not allowed to say what's happening on the news channel until 10, and then you can start talking about it because you're not influencing the vote. And then it runs all the way till 6 the next night. So you're doing a 36 hours shift of working on this. And about halfway through, the IT department came to tell us that that network card had failed at the top. And you probably lost access to your file server. And if you ask me how I'm feeling at this point, it's not saving data to the database. What are we going to do? We're not going to have the right results. The madness that made me cache every result in memory meant we could serve every result out of memory, and we didn't care that it was no longer writing to the file system. And unbelievably, it survived a complete network failure of an business IT network switch. So I was quite impressed that that was an accidental thing that happened. So as I said, we were doing DCOM, we were doing Workstation, we had a mixture of 16-bit and 32-bit clients. We even proved we could talk to a DEC Alpha workstation using a remote automation if we wanted to, just because they'd loaned us one to see how it worked, because we were in the graphics realm and it was a really good graphics workstation. The other thing we did, which there are projects where you can't be late, you have to deliver, right? There are actually very few projects where you can't get away with not delivering on time. You can always delay it a bit. The tram system might come online a month later. Maybe the TV channel launches a bit later than it should have done. But they won't stop a general election because you haven't got your graphics ready, right? So you have to do sensible project management, like drop features and things like that. Also, you've written this once every 4 or 5 years. That's it, to be used once. And you've done a big rewrite. You probably only got 4 weeks' notice, real notice of when the election is. They don't announce it 6 months in advance. A prime minister in the UK can go, we're having an election in 3 weeks, and that's it. That's when they'll have the election. So our prime minister at the moment could decide to have an election in 3 weeks, but he's probably not. It's probably going to be October next year. Who knows? So how do you solve the fact that you are writing code that has to work? It only has to work once. You can't move the deadline. No one's got unit testing at this point, right? We've got source code control. We haven't got unit tests. Well, it's really good. We'll run all our software in pause and continue. So Visual Basic, you could run code, and while it was running, pause it, edit the code, hit play, and it kept all the state that it had at that point. And that's how we ran it. So that meant that in certain points where it was showing the little strap at the bottom saying con votes, something, something, we actually had lines of code like if constituency ID equals 152, then con votes equals con votes minus 125, because they've gone and given us the wrong vote counts. And we edited that in, and then hit play, and carried on running the code. And you couldn't do a line continuation character, because it broke. So no one was allowed to do line continuations in the entire system. And every time you edited it, you had to copy it to Notepad and save it, because it wouldn't save any of your changes. And if it crashed completely, you'd lose all the edits. Only for this kind of software would you ever think that that's a good idea. And even then, you tell people about it, and they gasp. So that was an election using VB. VB was fun at that point. So by now, I'd left Sky, and I got really bored of writing data access layers, right? Because everyone at that point, you were going, right, I have a user, I need to load it, I need to save it, I need an update, I need a list of users, all that kind of thing. So at some point, everyone who's a programmer should write an ORM or a compiler. The two things you kind of write and then go, why on earth did I do that? You know, you can talk to Mark Rendell about this. He wrote simple data and things like that. So I was mad enough to have done both. I did a compiler for a children's playground software in Visual Basic, really old Visual Basic, and then I wrote this ORM. At the time, the guys in Java land, that was then Hibernate, or Hibernate. They'd created Hibernate. That got traction. As you know, if someone in the .NET world wanted to do a product that was like a Java thing, they put the word N in front. NUnit, NANT, NHibernate, NDoc, right? So they were coming out with NHibernate. Clearly, I'm tapped into the zeitgeist. I have no idea. I'm writing my own thing called RapidDB. No concept that this thing's happening at all. And I kind of did it between gigs as a contractor. And I thought, I'll just see how I could do this. So I wrote something that, what is it? It's 2004? Yeah, it's got to be XML. Right? You're going to specify the database in XML, right? Because there's nothing else that you would use, because that's what everyone uses. It's SOAPland and all that kind of thing. So you define the database in XML, and then you press a button, and it creates code modules for you. Right? So I went and wrote something that created code modules. This is before Roslyn compiler as a service. This is me hand writing strings out to code. Right? That's how it worked. And I made it work with VB, .NET, C#, 1.1, and 2.0, because there were 2 versions of .NET at that point, and Compact Framework for mobile devices. Because I'm between contracts, this is now an intellectual thing that I'm trying to do. I'll make it work with Microsoft Access, and SQL Server, because they're the two things I'd expect to use. While I'm there, why don't I do IBM DB2? What? No one's going to ask for that. MySQL, which I also wrote, and all the handling for Oracle. And Oracle's a lot harder, because if anyone's done Oracle, when you insert a row into a table, it doesn't get an ID. You have to ask for a ID beforehand and use that to insert the row into a table. So it works in a very different way. So all my code modules could handle all the differences between these databases and do it in C# and VB and generate the initial code for you, the boilerplate. Annoyingly, I didn't really pay attention to transactions, so they weren't in there, which is madness. And the other thing is, we didn't have partial classes yet. So once you generated the code and you edited it, that was it. You couldn't regenerate it because you wiped out your changes. However, QVC, the shopping channel in the UK, came over and said, can you do this system for us? And it meant I could roll the database and all data access for an SMS to screen chat service from their viewers to go on air, and I could do that in 2 weeks. And all of it was done for me. I was so proud of it, I went to the first ever DDD event, Developer Day in the UK, and talked about it. I put it on SourceForge, which was the forerunner to kind of putting things on GitHub, and it's still there, which is how I got the code that I'm going to show you. And at the same time that that was happening, Link to SQL had come out from Microsoft, which was a much better way of doing things, frankly. So I wasn't doing link, I hadn't got partial classes, and I hadn't got transactions. And because it was my first attempt at open source, I obviously wrote no documentation, because that's madness, and there's no maintenance on it. So no one's used it, apart from me, which is quite right. At some point, Microsoft killed off Link to SQL and brought in Entity Framework. At the time, there was a lot of people very sad about this, because Link to SQL was efficient and written by the SQL team, and Entity Framework was crap and written by the .NET language team, right? It was bloated and overdone. Only since we got .NET Core have they gone back to writing a decent Entity Framework. It's taken that long to get back to what they should have done in the first place. So I'm going to demo what this actually does. And rather than do documentation, you see, what I used to do, because Visual Basic type mindset, is you do an app that's a Windows format with loads of buttons on it, and you click them, and that shows you how it all works. So what you end up with is an XML. So this is your database schema first type attitude to how you should program a database and the ORM. And then Hibernate has both. You can generate from the class files, or you can generate from the kind of database. And this is definitely, I'm looking at the database. I wouldn't allow you to have any fancy data types, because it had to work across Access, SQL CE, Compact Framework, SQL Server, the whole lot, right? But you could have relationships and things like that. Also, did anyone get bored about the fact that every time you did a table, you had modified on, modified by, updated on, updated by, created? Yeah, all those get added automatically and are called rapid DB field with a yes, which means it boilerplates the right values in for you and into the system. So what this set of libraries did, let's see if I can run it, via this wonderful, tasteful UI, is you would load in the DB schema. Woo! How instructive that it says load OK. You would create the modules. So we have an empty directory here. I will create the modules. And there you are. It's created 3 C# and 3 VB modules. We have a database server over here with an empty database. I'll just check that I have deleted all the tables. So there's nothing in there. And I can go back to my little VB app. Wherever it is, it's now the Windows format there. And I can go create SQL 2005 DB, hopefully. It says created OK. Did it? Or is it going to error? Wait! Oh, no. Login failed. Right. And that's because that database is not accessible by ticketing. Right. That's so annoying. Let's look at the user mapping and make sure it can actually get to that database. Yes, it should. It should. So that means I've just got the wrong password on it. Great. Ticketing 2009, ticketing 2019, ticketing, let's have another go. It's probably not going to work. Oh, the database name's wrong. Well spotted. It's got the one that yeah, you're quite right. That should say NDC Porto 2023. Yay! And what you get at the end of the day is a load of tables that have all got all the columns you'd expect to have, all the relationships and foreign keys set up for you. And then inside your code, you've got a code module. And things like, so take an example such as searching for a company. I went and created classes where you could actually put in all the search terms you could possibly ever want, and then it would hand crank the where clauses. Look at that. And it did safe table names because I didn't realize that if you do SQL parameters, it does this for you. So I was making sure it couldn't have SQL injection. So all of this code, absolutely insane. I mean, the amount of work required to do this, you think, I did get that gig at QVC. That gig at QVC lasted for 7 years and funded the entire baseline of all the costs of my company for 7 years. So at that point, you think, yeah, it was worth it. You know, that was 40,000, 50,000 euros worth of income over 7 years. But I would advise you to use EF or Simple Data or Dapper or something. Don't write your own ORM. It's madness. It's absolutely insane. So that all seems a little old-fashioned and old school. So what about the web world? What about HTML? Well, one of the companies I worked for was called Hat-Trick Productions, and they did TV programs. And they wanted ticketing system. And what you should do now is go, you need to go to Eventbrite and just pay them and do all your ticketing there. But that's not what they wanted. They wanted to own the customer. They wanted to own the data, keep it all in-house, and be able to manipulate it. So what you have is a set of hundreds of people trying to apply for tickets and saying, I want 2 tickets, I want 3 tickets, I want 4. You show that data to the admin person, and they go, yeah, accept them, reject them, maybe think about them, we'll call them pending, and move them around. And it works really well when you get about 10 people wanting to do tickets. So this was web forms where they every time you hit a button, it posted back to the server with all the data on that page, fiddled with it, and gave it all back. And every time they said accept 4 tickets, what happened was 20 seconds of delay when it had 400 people in the list. It was okay when it had 10, but boy, when it got to the real amount, it didn't work. So I'm going, right, there must be something I'm going to do. How am I going to do this? There's Ajax, there's all sorts of things. Out of interest, here's another kludge that I did in this project. So I'm getting a database for Hat-Trick Ticketing. I've restored a test backup. I can't remember the admin password, because I wrote this 12 years ago. And who knows what password I put in, right? So I'm looking in the database, and there we are. It's good, because we've got a salt and a hash, and I'm going, I'm going to have to reverse engineer how the salt and hash work to get this. And I suddenly went, no, I didn't do this. I did something better than this. So what I did was I decided, let's just delete all the users from my database. Right? So now there are no users in the database. And what my system says, get this right, when there's no users is, you haven't got any users, do you want to create the first admin user? Bang. Right. Right? How good's that? When I looked at that, so I can happily just type admin and NDC Porto 2023. Whoops. There you are. So I've now managed to log in as admin. Everyone will go, that's a horrendous security fault. No, it's not, because as soon as you reinitialize the database, you log in within seconds and set up the first admin user. It's self-documenting code, right? How cool, you know? I mean, genuinely, that isn't a stupid idea, as it sounds. Don't do it in a banking application. That's the only thing. They won't like that. Remember that up to this point, if you had that in your code now, someone would be discussing, is it in the Octopus deploy secrets, or is it in Key Vault secrets? Were we putting that password for the first user? Because it should be scriptable, and we should be able to use IAC to put it in. And the whole discussion will go on forever, and someone could just run it for the first time and type it in. Right? Done. So this was the screen we got to. We got lots and lots of tickets. So huge numbers have got pending. Scroll all the way to the bottom. You can see why, if you post this back to a server, you've got a problem, because this takes forever, right? This was in the age where jQuery had come in. And jQuery was really good, because you could do things to the DOM. You could find controls, all sorts of weird things. And my thought was, I wonder what would happen if that row of the table, which I gave an ID to, if I just told it its parent was the other table. So if I just tell the browser, by the way, if I click on accept on this row here, your parent is no longer table pending, but table accepted. And I'll do that in jQuery. I'll just grab the control and go, your parent's this. And you know what happens? It instantly moves. Right, the browser just handles it, right? So now I have live editing, client-side, infinite editing of being able to go accept, reject, pending. So you'll notice, by the way, that you don't get to choose where it goes. It just goes to the top of the table, but I don't care, because that doesn't really bother me. But the other thing in here is there's a hidden field in that form. And every time you press a button, it has ticket ID, comma, how many tickets, and whether it was rejected, accepted, or pending. And it keeps doing that. So if I keep going, reject, accept, reject with the same one, that ticket ID is in there 5 times. But like any good event stream person, I had no idea what event streaming was. When I put that hidden field back to the server, it only ever deals with the last one added to the hidden field, and it ignores all the previous ones. So that's the state it got to. And bang, we have an interface where they can accept and reject tickets for an entire show in about 10 minutes. And the only issue they have is if they close the browser without hitting save, it all goes back to what it was at the very start when they loaded the page. And the code for this is unbelievably trivial and easy. This is all that you need in your JavaScript to move a table row. So pending ticket, table row name. So that is someone's hit pending. I move the table row ID to table body pending ID. That's this little bit of JavaScript. That's it. It's moved it. And then I call something called recalculate tickets remaining to make sure it works out how many tickets are left in the whole program. That's it. That much code. And previous to that, I was tearing my hair out going, how am I going to solve this problem? This takes way too long. Way too long. So yeah. So that was how I did HTML hackily. And it's really powerful what you can do in the DOM. And at the time, you might have been thinking about Ajax panels and updating and all sorts of weird stuff. But that was much faster. Much, much faster. And you talk to someone who is a front-end JavaScript, and they go, oh, yeah, of course it does that. But would you have thought a table row could just have its parent changed and it would just go dink on the screen? You just had to try it. So, and I stop at 2010 because I now stop at companies that either don't really exist anymore or haven't got a product or whatever, because you don't kind of say the dodgy stuff you've done at companies that still exist if you want to have a job. So this is for an MP3 file processing. So we had the whole of Sony's catalog, the whole of EMI, the whole of Warner Brothers. We didn't ever get Universal at the time before I left. And we got every song they ever did in full CD quality, lossless format, with all the artwork and all the metadata of XML files, because still XML, of where you can sell it in the world. How much can you sell this track in Czechoslovakia? Or can you sell it in the US? Can you sell it in Japan? All that kind of thing. Interestingly, this is the most storage I've ever really had to deal with, because we had 120 terabytes of storage in an office in Hammersmith, just in an office in Hammersmith. It was overheating a bit, and we had to put a portable aircon unit to drag the heat out, to get it all out of there. The heat was handy because anyone who cycled put their wet cycling clothes in there to dry out during the day. So you either had to be really secure and allowed to go near entire music library's back catalogue, or a cyclist. Right? One or the other would get you access to that room. EMI delivered this on 1 terabyte drives. That's a lot of 1 terabyte drives, to the extent it was on a wooden pallet and a forklift truck brought it into the office. Right? And it had to be wheeled into the office. And each 1 terabyte drive is connected to a proper HP Windows server that's only got USB 2, so it takes over a day to get 1 terabyte off over USB. It takes ages to get data off drives over USB 2. They had FireWire, but you didn't get servers with FireWire. That isn't something that you could buy, is server hardware with FireWire. And the initial team had been asked to do this in BizTalk, moving the entire raw files through BizTalk. That's 650 meg per CD through BizTalk, and they were struggling with it. And so what I came up with when we were thinking about it, I said, how about we just have a folder on the SAN storage called Received? And then we have the ID in it for the album. So each album had a unique ID from all the record companies. And we dump all the files in there, and there's just this Windows service ticking around going, if I see a new folder arrive, I keep polling to see if there's all the data's there. And the moment that it looks like it hasn't been updated for 5 minutes, then it's valid to process. So it's kind of like a message queue, right, in a folder. And the first thing it does is go to the XML file, tries to process it. If it doesn't work, it moves the XML file to a folder called error with the album title. And then it creates a text file where it writes in the text file what's wrong with that XML that it couldn't cope with. And then it kind of moves it to a folder called artwork. And it's really crucial that you move the folder. If you copy it, that's a very long process. Right? We're moving files at this point because they're quite chunky. And it tries to do the artwork, and every now and then they would send artwork that had really weird metadata that the .NET framework didn't like. So .NET Framework's image handling couldn't cope with it being the wrong way up or something like that. It was these funny parameters you get. You couldn't fix it in Paint.NET, but you could load it in MS Paint. Yeah. And then we would transcode as well. So we've done the artwork. We've done all the little thumbnails that you would expect on a page on a website. We've done the big artworks. We now transcode everything from lossless WMA. We're using FFmpeg. We actually bought licenses for FFmpeg, right? And I kid you not, we spent all of about £100 because the license was per machine you run it on or something. It was insanely cheap to run the entire system. And it would transcode it and make all the little preview files of the first 20 seconds as well as the main ones. If there were any problems, we'd do that. And if it all worked, it would go to complete, and that means you can now sell it, and it would start filling the catalog in the database in the e-commerce system, Magento, that this is now available for sale at these times because we've read the XML and we can now sell it in the US in about 2 days' time. The interesting bit is, how do you remediate? Well, you look in error details.txt and find out what went wrong. And here's the thing. We've done enough HTML validation forms that we tell you everything that's wrong. We don't fail on the first thing and then stop. We're going to tell you everything that's wrong so you can fix them all in one go. So that's quite cool. You hand edit the metadata, or you remove files that might have failed, illegal characters in file names. If anyone's got Macs, you can put a question mark in a file name on OS X. It's a legal character. Only it's not ASCII 63. It's some weird-ass UTF character. But it converts it to ASCII 63 on the fly when you actually look at it. So now we have people entering data with question marks in that when it looks on the SAN haven't got that character, so it now fails because the file isn't available. So we had to solve that. And then, as I said, we used MS Paint to fix any problems with bitmaps that didn't seem to work in Paint.NET or the .NET framework. And the way you replayed the job is you rename error-details.txt to .old, and then you move all the files back to the pending folder and wait for it to rip through it all again. So if anyone's done message queues and things like that, they've had to go into dead letter queues, they've had to replay messages, they've had to do this, they've had to work out why it died, all in files and folders on a file system, right? Which is logical because these are big files and you don't want to kind of muck about with them and copy them. And someone said to me, the CTO said, why had no one done this before? And I said, because telling people that you've learned how to move folders on a SAN isn't great on your CV, whereas saying about message queues and saying about BizTalk looks really cool and you might get a job. So this was a problem with CV-driven development, wanting to do the most complex thing possible on a job that absolutely screamed to be done in a very simple way. So the interesting bit is that if anyone's ever had drive letters and they're UNC mapped, so you have // server name, /name. If you use those to move a file, it copies it and then deletes the original. If you map a drive letter to it, it goes, no, I can just move it by saying that bit of the file, the directory is over here now, and it just does one little tiny operation to move the files. So we had to work out how we could map drive letters in Windows services before a user logged in, because you have to do that, because your drive letter mappings only exist for you logging in. They don't exist for everything underneath. So you have to actually manually encode map a load of drive letters. But yeah, all of that got solved, and we could suddenly process all this music. And we processed the whole of EMI, Sony, and Warner using that system. So it's really cool. And that's how you shouldn't write your software. So someone did ask, it was my CTO, goes, what's the takeaway? And the takeaway is, you will be forced to do compromises. You always will. That's software. Don't feel guilty about it. If it's actually a good solution, you can keep running it. The MP3 stuff just kept running. There's no point trying to think about that. That was a nice solution. Things like rendering the sunflower, that's a one-off. That's why you can get away with it. You should never have written it like that in the first place. But if you do write something completely hacky and you're going to have to support it in the long term, go back and refactor. Right, just refactor it. But don't feel guilty about writing it like that in the first place, because the whole point about software is to get it used by customers, by people, and find out if it works. And if it does, you can make it better afterwards. That's what you learn if you've worked in loads of startups. So that was, my worst code was my best code. Thank you for listening. Does anyone have any questions? OK, I finished early. Oops. That means you have a much smaller queue at the coffee. So I would go and get that now.